All right, to keep things moving, we'll go ahead and start up session 4, which is BMP operations inspection and maintenance. And we're lucky enough to have a couple of vendors that have products all around the county here and lots of information and expertise on the subject of BMP design and some lessons learned. So I've seen quite a bit out there in the field and what's gone right, what's gone wrong. And first off, we have Shayu with Oldcastle, and she's going to be giving some information, like I said, BMP design and lessons learned. And then we have Tamara from Contact who will be coming in. And then, depending on time, David Kirby will finish up session 4 with some additional interesting information. And just one last reminder, with your surveys, the table back before you exit there is where you can just set them down when you're done. I will turn it over to Shayu.
Hello everyone, my name is Shayu Zhang. I am with Oldcastle. A little bit of background about myself. I used to work in design in the consulting civil engineering world, and then I worked for a contractor for Metro for a while, and then now I'm with Oldcastle working for their precast department. Today I will not be speaking so much about our products, but I'll be speaking about an overview of lessons learned and what to consider when you're designing BMPs or designing with BMPs. This will be an interactive presentation, so if you guys have any questions, please feel free to raise your hand or speak up, and we're going to get started. So an overview of the items we're going to talk about today. We'll go through items to consider when selecting BMPs. We'll go through low impact development, stormwater quality designs options regarding pre-treatment and treatment, and stormwater storage solutions. The main items that I would say that we come across in the manufacturer, as a manufacturer, that we really see when selecting BMPs, or mistakes that some engineers will make, will be they either have not reviewed the calculations of the total removal rate or water quality flow rate, or they're not 100% sure what the regulation requires. So it's a good idea for design engineers to have a good idea of what calculations and regulations they have to meet when designing BMPs. Also, target pollutants and the available space and footprint that a project has, and the existing conditions and grading design, as well as budget, which is probably the most important item when looking at BMP selection, and the lifespan of the project and the maintenance requirements. You guys have any questions or comments? Move on to the next slide. So how many of you guys have seen projects that have been impacted, or how many of you have been impacted by low impact design? Should be every one of you if you guys are working in stormwater, right? So what low impact design or development is, the concept is that we want to mitigate impact of the historical and natural conditions of the site. What does that mean? That means placing bioswales or open space in natural low points, and it also means creating or not changing the natural flow of the water too much. It should be considered in the early planning phase, and that way we can prevent regrading or reworking sites, and it helps create more efficient design. Your possible solutions for low impact design are biofiltration, infiltration, and hydromodification, which just means storing water. And then we'll get into some solutions. So we'll go over some pre-treatment solutions, and typically for pre-treatment we use it with infiltration and storage. This pre-treatment helps decrease the amount of maintenance that is required for a biofiltration system or a filtration system. And last year at the CASPA meeting in Sacramento, they had stated that eventually all the pre-treatment devices that will be used will have to be on an approved trash capture approval list, and they're hoping to roll this out by 2019. And if any of you guys have any questions about that and you want to speak to me afterwards, please feel free to do that. There's some pictures up there of just some options that you have for pre-treatment: baffle boxes, inlet filtrations, or hydrodynamic separators. You can get them from several manufacturers. And Some other options for, these are some options or items to consider when designing treatment. Some options that you have for treatment are either biofiltration or infiltration, and it's just a biological component that will meet the pollutant removal levels of your project. The solution that you choose would be based on calculations and your regulatory agency. You have options between proprietary or non-proprietary solutions. So that might be a media filtration system, a biofiltration planter, or a high-flow engineered device. Do you guys have any questions? Nope. Okay. The next item we're going to talk about is hydromodification or storage of stormwater. When considering storage, the questions you want to ask yourself is storage a requirement? How much of volume needs to be stored? And do you need flow control? And most manufacturers can design these items into their systems. What are the space requirements? How much allowable footprint do you have on your site? And what is the maximum amount of depth that you can go beneath your grade? And given these types of constraints, which type of storage is best for your project? You have some milk crate type systems, you have plastic systems, and corrugated rail pipe and precast concrete. So there's several different solutions with many manufacturers that you can speak to depending on your site constraints. And depending on your site constraints, a different solution might make more sense. So other items that you should consider is that storage should be located near the discharge site, and it should be located somewhere in between the treatment and the discharge location. Back to the whole idea of low impact development, which is you want to keep it very similar to the original or natural flow of water. If storage and infiltration is an option with one system, that might be the most efficient way to design your system. Storage and treatment is an iterative design process, and it involves input from the key holders and several consultants. If you look at this detail up here, this is actually a detail that we had worked on with a civil engineer. We put a storage system underneath a planter system, so it is definitely possible to put storage systems underneath plants. It's just there are constraints that you have to design to depending on who the manufacturer is and what the product constraints are. Do you have any questions? Oh, go ahead.
What's the purpose of the storage then? Are you trying to infiltrate with that, or are you going to reuse that water? What's the point?
That water will be infiltrated.
Okay. A lot of our soils in this county won't infiltrate very well, so do you have a recommendation for maybe enlarging that so that it can be used for post-marine irrigation, or what do we do with all that water?
You definitely can make a larger system and apply a capture and reuse system and pump the water out and put it into a reuse harvesting system. In Los Angeles County, that's the case also. The soils are really difficult to infiltrate, and a lot of times there's not enough, the soil's not in a good condition to infiltrate, so capture and reuse is the second choice. So a lot of times you can do that. Does anyone else have anything to say about that?
Yeah, a lot of times we find a situation where the treatment volume and the hydromodification volume are not the same. And that's most of the time we see these situations is the decision's already been made, we can't infiltrate, so biofiltration is acceptable. Thus, the top of the design is the treatment. And then, but we can't release it any more than, our pre to post, and so we capture underneath and release. So there's various reasons it's used, but in what appears in that drawing there is that we're looking at a case where they're treating it, but their design volume and treatment volume don't match each other.
And I just wanted to make a point about this design in particular. Actually, it was created, or a civil engineer consultant actually came to us with this idea. This was not an idea that we had manufactured to come up with in-house. So I wanted to just make that point that we can work with different design ideas, us manufacturers. You know, there are different ways to use these systems, and sometimes it takes engineers being creative to get the best use out of something like this system. So we're going to talk about cost considerations. Again, designing BMPs is an iterative process. There's multiple options and multiple solutions. So I think best practice is always to involve manufacturers in the beginning stage of your project to find the best solution and the best, the most cost-efficient solution for your project and what makes sense. Another item to consider is that most manufacturers have standard sizes that they produce in. I always like to say we can make anything you want, but if it's custom, but it's going to cost more. So when considering design, you want to consider it at the early stage and use the manufacturer's standard sizes. And that way it can help reduce your costs. We want to help you guys meet your budget and meet your site treatment conditions. And also another item to consider is your total install cost rather than just materials alone. A lot of times I'm getting budget estimates or budget estimate requests from design engineers, and they just want to see the material costs when there is, you have to talk about or think about the installation costs and also the life cycle costs of this. How many times are you going to have to replace the system in the lifespan of the actual project too? So, and Tamara later will be talking a little bit about that, maintenance requirements also. So we're going to talk a little bit about space, surroundings, and existing conditions when designing BMPs. There's some questions you want to ask yourself regarding the space surrounding your BMP or structural BMP. What is your allowable footprint? How much square footage do you have to put a system in? And are there surrounding buildings or existing conditions that's going to affect the structural design of the BMP? Will it be in the footing of a building, or will it be within the groundwater table? This will affect the design and overall the cost and the lifetime and maintenance of the system. Also, what codes are you going to be designing to? These are questions that manufacturers are going to ask you right away when we're helping you design a system. We also want to consider the installation requirements during the design process. That means, are you going to put the system in the entrance of your construction site? Are you planning to drive a fully loaded loader over that system? Because probably then it's not a good idea to put a plastic system underneath that site location. So these are items you really want to think about when you are designing these. And then other items to consider. Considering or thinking about common sense items will help you save money in the long run. Considerations for pre-treatment and storage, these should be thought about early in the planning phase. Again, with the low impact development note that I had made earlier, this should be a partnership with your site design, it shouldn't be site design and then BMP selection. Another item is, and also, you want to keep drainage patterns natural. BMP should be at low points, and so that you can avoid reworking sites. Also, it's never too early to bring in an expert or a manufacturer to give you a second eye or second look at what you're designing. Sometimes I get projects way later on in the construction phase of a project, and the design is not done correctly, meaning the constraints, for example, will have a system and it'll have 5 feet of backfill or over 6 feet of backfill when the system can only handle 2 to 5 feet of backfill. So in those cases, it would have been better if we had seen the plans in the beginning of the design phase rather than the construction phase, and then the owner gets to avoid reworking the design and reworking through RFIs and costly changes. And the last item is that you really want to consider the life cycle of the product in relation to the life cycle of your actual project and the maintenance costs and inspection costs, which Tamara will talk about. And if you have any questions for me, my contact information is up there, and I also left a stack of cards for you guys to pick up. Any questions? Okay. Sean,
I was just curious, are all the PNP pictures either Old Castle or in some way Old Castle owned? Or are they
in
just generic?
in my
Graphic
slides, in my slides, they are generic 3D models.
Okay.
There's a lot of manufacturers that make them.
Okay.
And is that, go ahead?
Design assistance, things like that, for engineers included within purchases of materials or outside?
So for at least for us, and I'm sure Contact is similar, you know, for us, a successful project means a successful project for the owner or for the client. So we provide design assistance whether or not you buy the product from us. So, you know, if you come to me and ask me for a budget estimate, it's the same as you coming to me for a quote, and only I provide more engineering assistance. That doesn't, you know, just because I provide you with a quote doesn't mean I mandate that you have to buy it from me. So we're always here for questions and support, and Shelby can talk to that.
I think to add on to that is, I mean, we understand that all our solutions may not be the best solution for the project. So, you know, we work with civil designers, agencies, we understand, you know, what the site constraints are, what you have to design to, and we want to be able to provide you with a handful of different options. If ours isn't the right option, we don't want you to use it because it's not a successful project for you, it's not for us. We also understand that once that goes out to bid, somebody may have different ideas, and it happens. But we provide that design assistance as a service. Obviously, we hope at the end of the day we sell that project, but we don't sell every project.
And what I was kind of alluding to was from my presentation this morning was there's no reason not to contact vendors. Like some of these mistakes are just because people know they're not going to get someone else involved. So then we get the wrong system in the ground and it causes a bunch of issues. When it's just very practical to talk to the front, if you have any questions, you can solve all those issues without additional cost to you.
Right. Go ahead.
Does that include field service as well, like construction management or just inspection services, in terms of making sure that the device is installed properly, or from the perspective, when we see incorrect specs on plans that do get approved, right?
So it really depends on the project. You know, there's a lot of installations that contractors have done similar installations, but I would say when you're talking whether it's pipe, concrete, large detention systems, 95% of the reasons that a system fails is improper installation. Backfill wasn't done correctly, they didn't follow the backfill procedures, and that's kind of where things happen. So for most of those projects, we have on-site project management to make sure that they're following our guidelines. If they're not following guidelines, then we throw up our hand. We can't necessarily make them stop, but we can bring it to the attention of the owners of the site or whoever's on that, make sure that they're aware that this isn't going correctly. But yeah, I mean, we absolutely want it installed correctly.
If I can tag on to that, some of the things you're gonna hear in the next part of the presentation really connect to that. And I think what matters to most of you here is differentiating between everybody. And we're not talking about differentiating between whether Contact's better or Old Castle's better, but there are certain criteria that you should be able to ask a question, and anybody who's a quality manufacturer is going to say, just like Shelby did, yes, we will support field installation of these types of projects, or we won't, and here's why we won't. But if they won't have that open dialogue with you or with their sills, then I would be concerned, is this someone we really want? Because as I think everybody in this room is well aware, a lot of people jump into this game really quickly because they see it as a potential lucrative thing, and I mean, it can be. But how to differentiate is important, and that is a great question to ask, because if they're not going to support you in the field, something's missing.
To come on to that question, the field people that you guys would use, requested, are they PSCs, QSPs, or what's their qualifications as far as being on construction sites and making sure they're doing their jobs?
So in terms of QSD, QSP, I mean, we're talking something a little bit different than we're talking installation guidelines for a manufactured BMP, but I can speak on behalf of Old Castle. We're a manufacturer. We actually, we're a contractor as well, so we pour manholes, we provide precast concrete, bridge abutments, and we have project managers, field crews, people that are on site. So what qualifies them as an installation expert is they go on to make sure that vaults are installed correctly, to make sure that products are installed correctly. The installation guidelines are basically written by our design teams. We obviously, we have backfill recommendations, bedding recommendations. We want to understand the geotechnical conditions. Do we have the proper load-bearing capacity to make sure it can support the system going in? And then they're basically making sure that the contractor's following the installation guidelines as that product's going in. In terms of the QSD, QSP, I think you'd be looking at that more for a construction or during construction BMPs, or somebody that might be doing some sort of inspection of a post-construction after construction's done. But our people are qualified for the installation of that because we are contractors, we are manufacturers. That's what we do.
I'm kind of more interested in the trash capture thing you mentioned.
Yeah, we can talk about that. But the California Water Boards now have a trash capture requirement, and they have an approved products list that they would like to see their trash capture devices come from.
That's the regional board or the?
Yes, that's California State Board. Yep. Anybody else? Okay, then I'm going to hand off the mic.
Good afternoon, everybody. How you doing today? Good. Staying awake. I'm kind of disappointed the grapes are gone. I thought that was a great idea. Well, I'd like to start off by introducing myself. My name is Tamara Mammon, and I am the Stormwater Consultant for Contech Engineered Solutions from north of the 10 up through San Luis Obispo County. I'd also like to thank Xiaoyu for giving an awesome presentation on the design aspects to consider when using proprietary BMTs. Moving on, we're going to talk a little bit about the installation and maintenance of proprietary BMTs and some efficiencies and procedures to follow to make things easier for your designs. To start off, I want to begin with talking a little bit about some precast structure styles and what to look out for. First, you really want to pay attention to your submittal drawings to make sure that the pick weights are listed. These pick weights are going to include both your heaviest pick weight and the pick weight of each individual section. And then moving on to installation, it's very common to use a spreader bar when installing these. By using the spreader bar, you're reducing that pressure that can be put on the top walls of precast systems. Sometimes this pressure can get so extreme it can stress the system to the point of fracturing. That's why we recommend using spreader bars. We also note that chains are not typically recommended because they can cause chafing and binding at the corners that can be detrimental to your system as well. To pick up these units in your submittals, you should look out for your anchor type and who is responsible for providing said anchors. Finally, for installing these precast systems, you want to know your equipment capabilities. So when you are shipped a precast system, it is generally on a truck that's about 4 feet tall. When you imagine those picks, they're, say, 3 feet above that. And then your sling or spreader bar, whatever you're using to pick up this system, let's say is no less than 10 feet. You're already at 17 feet height restriction with those calculations. And as you raise that arm, you can pick up less weight. So take a typical CAT 330. When you meet those criteria, you just brought the lifting capability of this machine from 25,000 pounds down to 13,000 pounds. Also, I'd like to take a moment just to say this is an interactive presentation too. Feel free to raise your hand and interrupt at will, and we can get some of your questions answered as we go along. Another consideration to take into account with precast systems is the outer and inner dimensions. It's very important to look at the submittal drawings and plans before you go digging any trenches. It's a common misconception that people will look at the model number of a system and make some assumptions based on the outer diameters or inner diameters. So recommend going back, looking at that before installation. And finally, the overall height is also extremely important. It's common for foremen to be slightly off on their final grade. When you look at your overall height beforehand, that can save you the pain of having to go pick this system up, readjust the bedding, and then place it down. And it'll also save you time and costs. Well, looking at your site-specific details and your submittals, this is also part of where going to your manufacturer first is very important. So if we never see a project, then you're not going to get these. You're just going to have standard details off the internet. But anyways, while you're looking at these site-specific details, to find those inner and outer dimensions, that's where you're going to see highlighted in red in this plan view. For the overall height of the system, it's going to be right there on the side. And finally, the last item we talked about being important was the heaviest pick weight. As you can see, it's noted right there on all of the drawings, and it also has the weight of each individual section. Any questions on installation of precast structures so far? Yeah, David?
Are any of yours included with like media inside already when they're delivered to the site, which would increase the weight?
Yeah, and that will be included on the drawing as well. For example, if you see a filtration system or biofiltration system, it will note if the media is included. Okay, so moving on, talking a little bit about the bedding beforehand. Settling can be a very common problem. However, we have found that if you have at least those 6 inches minimum of your class 1, 2, or 3 material below these structures, settling should not be as much of an issue. As you can see in this example, they did not have the proper amount of bedding, and this is what you do not want to do. Transitioning over to specifically detention and infiltration systems, we're going to speak a little bit to HDPE, chambers, and corrugated steel pipe. In particular, the bedding, backfill material and processes, starting point, and nonwoven geotextile. So one of the critical components of all these systems is making sure that the bedding is level before you start placing the pieces. You also want to backfill and even lifts and make sure that you are not driving construction equipment over these systems until you get that adequate amount of cover, or else you're going to start seeing failures like we saw earlier. Starting point, before you even start going through plugging along and chugging, placing pipe, what you really want to do is look at your inlets and outlets and all the different connections. In this system, do you have any T's? Do you have any Y's? Do you have any elbows? Is your manifold overly complex? We generally recommend starting with the manifold and then building out. Finally, non-woven geotextile. As we saw in some of those standard details, there's going to be areas where it's required or areas where it's recommended or shouldn't be used at all. Very important to look at that ahead of time and know the areas that are required, know where to put it when it's recommended. And if you have any HDPE pipe risers, you want to wrap it in the non-woven geotextile to prevent that soil migration and settling. Do you have a question?
Yes, I did. I'm sorry, I feel dumb as a box of rocks, but would you back up to the last slide?
Yeah.
And explain to me what the nature of the mode of failure was on that unit to the right? Because I don't see a problem with that. It looks just fine to me. Where did it go wrong? What's wrong with the bedding? I don't see it.
This had an inadequate amount of bedding. And it's very hard to see from that angle.
But it was
I
placed
understand.
on native or something, or what's whatever. I don't see what the problem is. It looks level. It looks like it's fine.
Mark, would you like to follow up with that question?
It was placed on native, and
Placed on native.
yes, and at that point, it does look great, and that's a real key to all of this, is that things can look great until they get backfilled, and it's during the backfilling that all of a sudden differential settlement can occur, and you don't see it, and next thing you know, you've got a system that leaks. So, but yeah, that is a very valid point. Things look good, unburied, and knowing ahead of time this is what needs to happen is very important.
Okay. Starting off with chambers. With chamber systems, there's some additional materials you need to consider. For example, right underneath the inlets of these systems, you're going to need a scour netting to prevent erosion of that leakage. Next, you are going to need your Tensar GeoGrid, your C40 non-woven geotextile, and finally, you're going to need 4-inch PVC inspection ports with caps for all of these systems. Moving on to the backfill sequence for chamber systems, you're going to start with even lifts distributed across about 6 to 8 inches high. You want to be very careful you're not overloading one side of the chamber at a time. That can push these lightweight chambers and misalign your whole system. So as you're going across even 6 to 8 inch lifts, for top loading restrictions, you can't even get on top of these systems until you have 6 inches of cover from the top of the system. And then once you have that 6 inches of cover, you can have small, lightweight excavators or walk-behind compactors. The vehicular loading is not allowed until you have a full 18 inches of cover. And again, when we say vehicular loading, we want to be very cautious and point out that that is different than construction loading. Construction loads can cause point loads when they're pivoting and turning their machinery, and that can be catastrophic to some of these systems and result in some of the failures we saw earlier. For corrugated metal pipe and detention, there's a very common misconception that for using stone in these large diameter systems, it's just going to go ahead and settle in those haunches. That's not the case. You're still going to have to go in there with a shovel and slice it in. It's very similar to the chambers and the backfill in that you're going to want to do 6 to 8 inch lifts on either side of the pipes evenly all the way across to prevent the runs from migrating side to side. You also have all the other considerations to take into account. So, is there going to be a geotextile fabric? What is your loading going over these systems? For some of them, if you have a higher gauge pipe or adequate cover, it might have a different loading restriction. And finally, how are you going to backfill? So you can use a conveyor to backfill, which can cause some cost savings and it will reduce the risk, increase safety. Or you're going to use a backhoe for backfilling. In addition to that, another cost-saving measure some people like to take is with conditions of deep cover, they stop using their class 1, 2, or 3 material at a certain extent and start using, say, native backfill. This is usually fine. However, for systems under 60 inches in diameter, you're going to want to use at least 6 inches of that class 1, 2, or 3 material above it. 66 to 96 inch diameters, at least 12 inches, and 102 to 120 inch diameters, you're going to want at least 18 inches of that cover. And then depending on what backfill you're putting on top of it, you might have to put a fabric down before you go ahead and add the extra native material. Finally, precast or concrete detention for detention and infiltration systems. There's various manufacturers that offer these in various different designs and considerations. Again, it is very important that you take a look at your submittal drawings before you proceed. Also, some of them require foundations and other ones do not. When they do require a foundation, very important that the keyway is poured accurately. And at this time, I wanted to ask Xiaoyu or Shelby if they had anything else to add on this slide in terms of precast concrete detention as to what to look out for installation.
So the thing with concrete, and I'll just say it, is most of the time designed correctly, precast concrete is going to be something that you can pretty much drive over almost instantaneously. Vehicular loading, you still want to watch for backfill that it's done properly. Some people will design with concrete thinking, okay, it's concrete, this is kind of the top system that we can put in. But the mistakes that are commonly made is they don't properly backfill. So though that structure doesn't move and it's sound, the backfill isn't. So you'll actually have a failure of the backfill areas, not the structural area of the superstructure itself. So there's definitely things you want to consider when utilizing concrete. There's things that you want to consider when utilizing all the different systems, and just ask those questions. And that's why we want to work with you guys up front and just kind of be upfront and honest about here's its strength, here's its weakness. Here's 3 different options. this information can be presented to, whoever, to you guys, the governing agency, the owners, and then decisions can be made as to what's most appropriate. But even concrete has its weaknesses. So I would just say that make sure that the backfill and the installation guidelines are followed per our specifications.
Since concrete is pretty heavy, most of the time it's gonna require some sort of crane to set it. Some systems, if they're small enough, you can use an mini excavator to set them. So I think it's really important to understand this in the beginning when you are designing, to understand that you might need some heavy construction and access.
All right, thank you guys. Any other questions on installation and detention infiltration systems? Yes?
What's the purpose of the netting underneath the chamber max 2 slides ago?
That right there, the geogrid?
Is that netting on the left picture?
Yeah, that's the scour netting. So you generally put that under the inlet to prevent erosion at that area. Because these aren't they're not watertight systems. You are going to have some of that leakage at the joints. Any other questions? Okay. At this time, I'd like to talk a little bit about the maintenance of our pre-treatment or filtration systems, starting off with hydrodynamic separators. HDS or hydrodynamic separator systems are not seen as maintenance-intensive products. However, the amount of maintenance can often depend on the site conditions the product is in. For inspection, we recommend that you inspect 1 to 4 times a year. The process could be accomplished without entering the system. The typical tools you need for this are a rod, measuring tape, and a recording log. And when you go ahead, you're going to record the sediment loading of the unit. For maintenance, all you need to do is stick the vacuum truck down, remove the floatables, sediment, and standing water, and clean the interior. And you guys saw earlier, sometimes this can take only 30 minutes in some cases. For filter devices, in specific the membrane or media filters, it can be a little bit more intensive because you're capturing a finer particle size. In addition to this, when you have cartridges that are a higher flow, they might need to be maintained a little bit more as well. The frequency that we recommend is generally 1 to 2 times a year. Most of these systems can be inspected without entering. Again, you're going to need that tape, rod, and log to inspect it. And some of the filters even have visual indicators of when they need to be maintained. For maintenance of cartridge or filter media membrane filters, you're going to need confined space entry. What you're going to do is have the vacuum truck go in, remove the floatables, sediment, and standing water. After that, you can go in and replace the filters, and then you can clean the interior of the unit. Finally, with biofilters, again, you're going to have a high or a low flow media type. Those higher flow media types are going to need to be maintained a little bit more frequently. We recommend you inspect these units 1 to 4 times a year with routine maintenance every 6 to 12 months, so generally 2 times a year. Some sites may require more frequent visits depending on the site conditions, and these are generally considered the easiest manufactured systems to maintain. Do you guys have any questions about inspection and maintenance routines with any sort of filtration products? Yes, Craig.
On the filters,
Mm-hmm.
I know it looks like you guys removed the whole unit from all the filters. So there's that whole question about stormwater. Is it examined as included, is it not? So is there a disposal requirement for those? Do those have to be wrapped? Do they have to be sent to hazardous material place? Or do they just go to clean or they go to the dump?
I'll have Mark start off answering that, and then I'll follow up with
Typically,
what was he saying?
stormwater is considered, what's captured in one of these stormwater treatment devices would be no different than its standard catch basin.
Mm-hmm.
So the processes that you use for your catch basin cleaning would be the same. I know there are some places that take that material and drain it, let it dry, just to make it lighter.
Mm-hmm.
But as far as being a hazardous type of equipment or material, it is not at this point in time. Obviously, very subject to change as this whole industry, the requirements keep changing, getting more stringent daily, but at this point in time, there's nothing hazardous considered about the material that's been captured. Did that answer? Well, that would depend on the company. In our case, we take them back, we refurbish them, and they get reused. It does depend very much on different companies, because not everybody has the same mechanics that get done. So I can't really speak for other people, but they're generally, to my knowledge, they are just taken away. There's nothing that's hazardous about any of it.
And from a maintenance standpoint, with that video, you saw them go in and they Vector trucked all the media out. That's just so it's easier for them when they have to go in that confined space entry, they can just lift up the lightweight plastic cartridge to recycle it versus having to lift up the cartridge with the media in it. Okay. Yeah, no problem. So some concluding thoughts I wanted to leave you guys with is that inspection and maintenance manuals should be included in your submittals along with a maintenance log. These should be provided by the manufacturers. Also, it would be extremely beneficial to your project if you had BMP maintenance included in the original property deed. This ensures the longevity of your system and just provides that extra safety measure of the fact that these are going to be maintained in the future. And finally, you've noticed that I spent a lot of time talking about installation of detention and infiltration systems and then went over more the maintenance side of pretreatment. The reason I did this is if you are maintaining and have a pretreatment system before your detention and infiltration system, you will need to maintain that detention and infiltration system far less frequently than if you didn't have it. Right, at this time, I would like to open it up for any questions you all may have.
When we're contracting these devices, when we're looking at the site-specific details,
Uh-huh.
I've seen do-it-yourself detention system, I've seen proposal, I've seen contract, and I've also seen fabrication.
Mm-hmm.
Which details should we be looking for to verify that that's a site-specific detail in the contract phase?
So as Shai, you mentioned, a lot of these processes are iterative and we update them as they go along. So DYODS is generally just an engineer, somebody went on, they got a quick sizing and put it in their plans. They have a proposal drawing. They contacted us for at least preliminary sizing and a quote. Contract drawing is after we have everything, it's said and done, and we have a site-specific detail for them. So I would look at the contract drawing as your final submittal. Yes. Oh, sorry.
As contract engineers, I've never approved a plan that was not site-specific. You know, when you put your sheets, which are great, and it has the design. If the civil engineer didn't contact you guys and told you, hey, here's my elevation, top is here, and all the inverts on the pipes, I won't approve that set. How much involved do you guys get with the engineers? Do you follow up with them, or do you wait for them to come to you? Asking for it is really easy, it's just a red mark on a set of plans, but do they come back to you guys? What's
Yeah, there's two separate questions here, because I do want to go back to the first one. Plan check, in my mind, and you folks are doing it, not me, but there's not just one phase of plan check. We have a plan check where it's at the WQMP level, where people are deciding, are we going to be able to build this project or aren't we? And then there's a second plan check when there are submittal drawings, when the project's actually getting built. They're the construction drawings. And that's part of why we have different sets of drawings, is that the detail and cost that gets involved in doing the construction drawings is significantly more, and as Shelby said earlier, we understand that we're not going to get every job, but at the same time, we have layered the design that we do because of that. We try very hard to follow up with civils and get the information. There's a lot of things that work against that. In some cases, it's just a civil being too busy and they're not getting paid anymore. It's not billable hours, so they're not responding to us. In other cases, once something is out to bid and out for contract, we're not the appropriate person to ask a question. And so it's got to go back through a contractor who may or may not be as diligent as we would like them to be in trying to get the answers that we need. But generally speaking, we feel it is not in our interest to build something without complete information from the civil. So we will sit and wait, and Shayu and Tamara will circumnavigate the contractor at times to try to see if maybe we have a good enough relationship with the civil to move things along a little bit for us, because they want their project to build. So there's a lot that goes on, but I would say the quality companies are really making an effort to try to get all the information, because when something gets built wrong, even if we can wave our hands and say it's not our fault, it's still a problem, not just for us, but for everybody, and in the long term, that's not a good thing.
The only thing I would add is we absolutely want the engineers communicating with us. Absolutely.
Well, the agencies are asking them to do so.
We're available.
Yes, the more the communication, the better. And feel free to, I also left my card up there alongside Shayu's if you guys want to take any of them, and if they ever have any questions, just go ahead and send them our way.
Our engineers, when we get requests for bids and requests for quotes, if it's not designed correctly, we will hunt down the engineer, because we can't provide a quote for a system that's not going to work. And also, the submittal contractor drawings is our last check. That is our last fail-safe before we manufacture a system and it gets made, that everything is in place. Yes?
Getting back to what you said about phases.
Mm-hmm.
So you talked about WQMPs, that's really important systems.
Yeah, sorry.
Yeah, no problem, I deal with both. Would you accept for WQMP or PCSMP proposal drawings?
Yes,
Okay.
they are very close to site specific enough. The things that are missing are elevations on risers and stuff like that. But as far as the volume, the footprint, the loadings, everything else about them is going to be accurate.
Okay, so then in that phase, then proposal details, okay, but then for the final phase, when we're going to final plan check, we're going to make sure that it's okay, thank you.
Any other questions? All right, well, thank you guys so much for your time.
Can you hear me? All right, making sure I'm energized here. All right. So, Jim, are we okay to go? Perfect, thank you. So I want to thank Contech and Oldcastle for joining us today. As we talked about in the morning presentation as well, I think it's very important that we have vendors that we typically see a lot of their stuff in the field, a lot of design reviews. For me personally, I probably see 50% proprietary stuff that comes through across my desk. So I think it's important that everyone kind of understands that they're there to help and to direct engineers to their assistance if we see that they're not being fully implemented correctly within design plans. So I'm just going to go over some more stuff through the county to kind of close out today. I appreciate you all being so patient. Haven't seen too many bobbing heads, which is always a benefit. So what I'm going to be talking about today, or this afternoon portion, is more examples of stuff that I've seen, design, construction. On this side, we have a project that was designed with filter strips as their biofiltration requirements. So at the end of their discharge points, they have energy dissipators, and then those would disperse across these filter strips, and they had 2 of them at their 2 discharge points. And then here's just a general picture of what filter strips generally are. Very flat, have to be about 15 feet in length so water can flow through it and filter. So at the end of the project, I got a call saying we need the final inspection. I go out there and there's no filter strips at all. All they did is expand the energy dissipators for the rock riprap. So this happens quite frequently. We've done a lot of efforts with the county to train our grading and building and permit safety staff to make sure that stuff like this doesn't get missed, because once it is, it's very difficult to get them to do it again, or to could be very costly for them to do it. This is an example of it's an older project that was going through SQUIMP. So this is back in about 2008. It was initially approved, and then I started at the county 2013, and
This is in my first week starting with the county. Got called out for this inspection. Basically, it was construction had already been completed of this. It was a development where they're supposed to pave the roads adjacent to, so like kind of like similar you see here. There's kind of like a parking lot, and it drains into filter strips for pre-treatment, and then it goes into an infiltration trench in the middle, and that's supposed to be on both sides. So this is what you're expecting to see when you go out there, and this is what actually was seen. So they ended up during construction saying, you know what, we're not going to pave this at all. We're just going to keep it dirt. We have some equipment driving around, and to protect it, they put up some bollards to make sure no one drives on it. But right here, it's just going to be sediment impacted, and this whole thing is not going to be functional within a year. One rainstorm, this thing's not going to work. The TGM does have some specific layouts for what you can do for infiltration testing. So there's 3 different methodologies they outline in there. If you look at different, LA County has different similar processes, but they have slightly different wording, different ways to do the testing. So if you look in Appendix C of the TGM here, it identifies these 3 different methods. You've probably heard the double ring infiltrometer, generally for surface flow, or if you dig in a trench and then put that down maybe 5 feet down, you can do some subsurface as well. The Guelph permeometer, I'm not familiar with myself. The one I've particularly done the most is the falling head permeometer, and that's where I'm doing the shallow borings as well as the deep borings for my infiltration testing for the projects. This is an example of that being done. So we've already bored the holes, we have the gravel backfilled, and we're just doing the water test to verify once it's pre-soaking how quickly that water is draining out, so we can get calculated measured field measurements for infiltration testing. This is the one project I talked about earlier this morning, where I did the conceptual design for infiltration. The infiltration rates came back terrible, so I had to revamp the whole design to go to a bioswale. And this is the final results from there. So here we did section 2 to 5 feet down, less than 1/4 inch, 9 to 14 feet down, still the same thing. So we're just hitting a clay cap all the way through. We found one location where it was mildly okay, but not enough where I'd feel comfortable doing a full design for infiltration. In Appendix F, there's also, they outline how to implement flow splitters. So this kind of goes back to our discussion earlier about making sure that if you have a BMP, you can try to do it offline so that you're not putting all the high bypass, all the high flows from large rain events into your BMP, because it could be devastating to your O&M plans. So this is 2 different concepts that they have in the appendix. The first one is just basically a weir wall within a manhole. So you say you got like an 18-inch pipe coming in, you've got a weir wall that's sized per the hydrology calculations for that 0.75 inches of rain, and then you have your pipe, your low flow pipe going to the BMP itself. So say here it's 8 inches. So once your whole system downstream gets inundated and filled up with that 0.75 inches, the water in this manhole would overflow over the weir and then bypass. So in a large rain event, you wouldn't have those high flows inundating your system and causing potential erosion and other issues. Similar setup here on the right is in this one, it has overflow pipes. So this whole sediment manhole fills up. The bottom pipe of this pipe going to the treatment facility is usually has like a mesh screen or something on it so it can catch some floatables, but the water flows up and through. And then as this fills up, it also has an overflow on the top. But then once in large rain events, this fills up all the way, it overflows into this big pipe, which you can see here vertically. So it's like a vertical elbow that goes out to your bypass for the large events. This goes into the same idea. So this is figure 6-1 from the technical guidance manual. And what this shows is different configurations you can do for your BMPs. So we talked about online BMPs. There was a question earlier before lunch. Can you put everything to one BMP, both your high flows and your low flows? And yes, you can. But it's generally recommended to do an offline configuration, which is utilizing like a flow splitter so that your low flows go to your BMP and your high flows bypass. So these are just those different configurations in there. This is an example of one that we constructed out at that Happy Valley bioswale as well. So the natural progression of water through the existing storm drain system is the blue arrow. So it hits that weir wall, and so the low flows will be diverted into our treatment facility with the green arrow there. This is one where we actually put in an adjustable weir wall. So the weir you see there is only 6 inches high. We have 8 inch as well as a 12-inch that we can put in there so we can divert more water if need be, and then we can just adjust the restrictor plate on that 18-inch pipe going to the treatment facility so that we can allow that amount of water going through.
Why would you want to adjust that after you design it?
Well, one thing is we designed the 6-inch weir wall is for the water quality volume that we were wanting to do for our project. And if we start getting really good numbers, we want to be able to divert some more water. The idea there too is we didn't want to inundate the facility with the 12-inch weir initially while we're doing plant establishment. We didn't want them to drown if there was some ponding. So we went with a 6-inch with the possibility of adjusting it. This is the government center. I've talked about this a few times. It's been brought up with the dry wells that we put in. Observation wells are critical in my mind to long-term monitoring of infiltration projects. So at the government center, we have over 400 dry wells, as I mentioned earlier. Here we have about 50 of these observation wells. So it's just a 4-inch perforated pipe down the middle of the 12-inch dry well, and it's covered in a sock, so you don't have any kind of sediments getting in there. But it is able to measure the water. So what I end up using is a solence level logger. So it's about a 4-inch logger. It's basically a pressure transducer, that's all it is. So it just measures the weight of the water column above, and it gives you a reading. So I put it in before a rain event, bring it back after the rain, or go get it after a rain event, plug it into my computer, download the data, and this is kind of the resulting. So on this, you see the orange is the rainfall amounts on the right axis. So in the first day, you can see the orange spiked up and we got about 1.5 inch or 1.1 inches of rain in the first day. And the blue one is the water column above that pressure transducer. So you can see that goes all the way up to about 15 feet, the bottom of that dry well. So we know that in that first day, that entire system filled completely up. And then when rain stopped, then it started draining out. And then it filled up again when it started raining, and then drained out and filled up again about halfway. So we can also measure our long-term infiltration rates into the soils this way because we know the volume capacity within those dry wells based on our designs and what was constructed. So we can calculate what that volume is actually going into the ground. So this is one way we monitor our long-term infiltration at the government center. Inspection, maintenance, and operability. So I just wanted to touch on these. In the MS4 permit, it requires all publicly owned BMPs to be inspected at least twice a year. And privately owned BMPs have annual verification requirements. So we do our own internal inspections of our post-construction BMPs. I believe the county's got just over 40. So we do those every 2 years. And the privately owned ones we do annually with mixed results. Here is the pervious concrete. So Troy had brought up the idea of the pretreatment with pervious concrete. This is kind of what it looks like after a rain event. So we got the disgusting water on the left that's coming off the parking lot. And then the resulting after the storm event, once all the water's kind of infiltrated, you get this gooey substance, all the oils, things like that kind of stuck in the pervious concrete. It also does fill with sediment. We've done some cores in the past after about 2 years in the field to see how far down the section of the pervious concrete actually gets plugged. And it's really only the top 2 to 3 inches. So the pressure washing and vacuuming we do is actually quite effective. And this is the equipment we use for that. This is something that's fairly new. It's a company called Bunyan Industries creates a system. It's called the Bird system. And it's got 12 pressure washing jets in the head, as well as suction and a rubber gasket around it that's adjustable, so you can always make sure you have good suction on the ground. And then you just pull it along like a household vacuum kind of thing, and it just sucks everything up while it's pressure washing and loosening up those sediments. So we do pre-infiltration testing as well as post-infiltration testing of the surface to see how efficient this is. So initially we budgeted to do these cleanings about 3 times a year if needed, but we found that doing it twice a year is sufficient. So we usually do it once before the rainy season and then once again after like a major rain event is what we'd like to do. These are some of our inspection forms that we have from our post-construction county inspection. So this is at one of our fire stations, I believe. So here we have a biofiltration area, and this one came back. We don't need to go back and inspect this one. So in here, there was no water backing up. It was flowing through, it was draining down. The vegetation's been trimmed down. We normally want to see if its grass is between 4 to 6 inches maintained in that height range. If it starts getting too long, it folds over, kind of works as a dam, and then you can have some ponded water and vector issues. So this is an example, one that we were happy with when we went out for the first inspection. This is one that wasn't so lucky. In the right side there at the top, you have a detention basin. All the vegetation's dead. It was vegetated a few years back. The only vegetation that seems to be taken foot is at the discharge point of the head wall. So all the water coming in, which tells me that there's obviously some water ponding here, which is why there's vegetation thriving here. and it was clogging or getting into these inlets, so we have to make sure that those are cleared out so we're not actually having issues during a large rain event. And then the non-vegetated swale in the pictures there. We have some great pictures of when it was constructed, and then it just, all the maintenance completely went. Either didn't maintain it or didn't irrigate it at all and just forgot about it, but that used to be a lush vegetated swale. So now we're working with the ground services of this facility to bring that back up to par. Some more examples here, just some poor maintenance. We do run into this a lot at our own facilities, so we try to focus a lot on training, making sure that each person responsible for that maintenance understands its importance and identifies certain areas like this. Just even routine trash maintenance. Could have every day, if they walk around, or every 2 days walk around, pick up trash that's lifting, you wouldn't have all this stuff. The vegetation, again, is fairly overgrown. In this case, it was kind of clogging the inlets, or the overflow inlet, sorry. This is the sedimentation manhole of a dry well system. So Troy had showed us earlier the Maxwell Plus from Torrent. That one has a sedimentation manhole, and then it goes into a bigger dry well where the actual infiltration takes place. So in this case, we have standing water in the sedimentation manhole, which tells me the infiltration system is completely plugged. So this is what the sedimentation manholes typically look like. So we'll have weep holes at the bottom, or sometimes it's just gravel on the bottom to drain out any water. But we have standing water, so this whole thing has been plugged. And that's what I'm talking about there, is a sedimentation manhole before it goes into the actual infiltration device. So this is one that obviously was not maintained in the 2 years that we waited to do those 2 inspections. More vegetated swales. So constructed on the left, approved it to go, tested the irrigation during the inspection. 2 years later, that's what's left. Not maintaining the irrigation, not doing just standard maintenance or just checking on it even, resulted in this. So it's an uphill battle, but it's something that we all, I'm sure, run into in the municipalities, but it's something that we've taken to heart and really start working closely with all of our ground services maintenance personnel. Here's a couple more. So this is when we went to an inspection first. Both of them are different bioretention systems. So we have the first one at the top, obviously overgrown. You can see all the vegetation is folding over. It wasn't draining properly. Once they went in there and did some minor sediment removal around the inlet and then cut the grass, it started draining fine. The second one, we have overgrown vegetation. You can see in the bottom right picture, here's the outlet pipe, or the inlet pipe, sorry, for all the water to come in and start filtering through. And it was clogged from this vegetation, so they trimmed it down. In areas where the vegetation had died or just hadn't taken, then we did allow them to do some mulch until that other vegetation did pop through. This is our pre-treatment baffle box at the Happy Valley Bioswale in Miners Oaks. If you're ever up near Miners Oaks Elementary School, right adjacent to it on the Ojai Valley Land Conservancy, we teamed up with them for this project, and we have this at grade with a see-through vault lid. So you can walk by and see all the trash that's actually getting captured, the sediment and all that. And it's right next to the elementary school, and you see kids looking through there all the time. So trying to get us out there to, all these kids to understand what they're doing when they're littering, things like that. But this is after the most recent rain event. So at the end of, start of January, after the Thomas Fire went through, we had this cleaned out, and this is what would result after the one rain event. So this vault has about, I think it's 9 cubic feet of sediment storage, and it was completely taken up from that one event. So when we're doing maintenance of it, we have a Vector truck, and then lots of times the sediment's dried out or it's all compacted in there that we have to use pressure washing just to break it up so it can actually be vectored up. And then at the end we have our vault. The one thing I do want to identify here is in the vaults here we have these deflectors, so right when the water comes through it disperses it and allows sediment to kind of settle here and minimizes some of the force of the water coming through this unit. But even in here, it's an 18-inch pipe, and if you watch this during a rain event, it really just flies through there. It's amazing the force that the water from an 18-inch pipe has. So I want to get into costs. So I put together a table here. This is a few of the projects that I've worked on since being at the county. So we've got the Happy Valley Bioswale at the top, our Piru Stormwater Capture project that's under design right now, and then Saticoy Subsurface is another one that's within design. Our government center pervious concrete, and then we put in a bunch of full capture trash devices as well, the connector pipe screens. So what I've wanted to show here was generally the construction costs compared to a 20-year life cycle cost on this side. So you can see here 20 years of O&M based on what we're doing right now, and the most efficient way of us doing it's costing about $26,000 a year. We partnered with OVLC on this one, so they're doing all the landscaping and maintenance, and we're doing the vault cleanings. So you can see that the 20-year lifespan for this project is more expensive than the capital cost. For the Pyru project, we're anticipating $688,000 roughly for maintenance of 2 CDS units as well as a small sediment forebay at the end of a large discharge pipe. And again, we are sharing maintenance costs here with United Water actually for this one. So they're taking this and we're doing that. So you can see again, 688 compared to our construction cost is fairly significantly higher in this case. We just got lucky and didn't have to design an infiltration basin. That's where we came up with United Water. We approached them and said, can we use your spreading grounds if we divert water to it and do pretreatment? They said, yeah, we'd love the free water. So I also want to kind of point out the need for agencies to put projects, like large projects, in the ground. Teaming is the best way to do it. We've gone after a lot of grants, and most of these are being constructed under grants. So we're able to do a lot of cost avoidance that way by not having to pay the full cost of the projects. The government center is another one here. So 1.4 million, and over 20 years we anticipate spending about 1.3 million on just O&M. So the pervious concrete cleaning and permeable pavements, from my experience, is about $1 per square foot to clean each time you clean it. So at the government center we got 22,000 square feet of it, so it's a costly thing, but it works exceptionally well. We are able to infiltrate about 700,000 gallons of water every time it rains. So it's something that is in some case worth, depending on who you talk to, if that's worth it or not, but to me it's definitely worth it. And then our full capture screens, we put 112 in the ground total, and then we have our O&M costs for those, because the screens are very cheap to put in generally, so the O&M costs heavily outweighs that. So the whole discussion on cost, I just want to exemplify or really highlight the point that the O&M is your biggest cost. Most people think about the capital cost that it's cost to put in the ground, but coming up with that yearly amount every year to come up and pay for all this stuff is a challenging ordeal. The International BMP database at the bottom, if you look at all their BMPs, they generally do it they give some prices for long-term maintenance and annual maintenance based on impervious acre treated. So they'll do it for bioretention. They have a bunch of different reports that identify what it costs for swales to maintain, and the general range is from $400 to $3,000 annually per impervious acre. So at the government center we have 39 impervious acres that we're treating with the 22,000 square feet. So it's a very small footprint for the BMP to treat a large amount of water at that location. Try to come up with some other sources. Yes.
There is not a column there for construction costs per acre treated?
There is not here, no. So we just have the full construction cost for the project here. I didn't break it down by impervious acre here, but I did for the O&M. So here you can see all of these areas generally fall within this range, and usually the lower end of the range. So that is something when you're designing projects, you should be thinking about the O&M and what this is going to cost. For instance, if say the city of Thousand Oaks bought a Vector truck to do this stuff in-house, a lot of the pretreatment stuff you're putting in a future project should also require a Vector truck, so you're using the same equipment. You're not having to hire someone else to come out and do confined space or things like that if you don't have to. So it's trying to think ahead and keep similar equipment helps a lot with long-term costs.
I was just thinking something along the lines of a net present value for the cost plus the maintenance would give you a comparison of BMP.
That's good point. I believe the BMP International database has that if you look deep enough. I mentioned earlier it's somewhat cumbersome to kind of go through and find exactly what you're looking for, but most of the information is there and it's reliable from reliable sources. So I was looking through some more examples of where costs can come from when you're trying to pitch anything to like a board of supervisors or anything like that. Is, well, how much is going to cost long term? Even if we put this project in, how much are we going to have to come up with annually to pay for it? So this is a document or a book that I received at a conference I went to last year, and it's the cost of maintaining green infrastructure. It's really well broken out. They have BMPs from all over the United States. I think there's about 30 different states that are included or submitted some information to it, either from cities or counties. And then they identify what their costs were for construction, and then down here they also have it normalized for maintenance cost data. And in this particular case, for dry ponds, wet ponds, vegetated swales, they actually break it down by the volume it treats, as well as personnel hours personnel costs per year in general. So it really goes down a few levels to give you some detailed information to what you might expect for these types of maintenance projects. Another one is through the EPA. So I just included the link at the top. So they have some detailed reports on cost analysis as well as cost-benefit analysis for different types of BMPs, how much they're treating, how much maintenance costs, and some different recommendations as well. To go back to the pervious concrete, another item is during the design process, there's lots of things that can save you money. Obviously, Oldcastle in context spoke to that. There's also different ways of doing construction. So at the government center, this is the poured in place pervious concrete. So for larger strips, we use a conveyor belt to drop it in easier. The problem with the poured in place is it has to be covered with sheeting and pinned around all the edges for 7 days before you can drive any vehicles on it. So at the government center, where we have it in every single parking lot, that became a huge issue. Trying to coordinate with our ground services and closing off parking lots to make sure people aren't driving on it did become a big headache. So in retrospect, it might have been better to go ahead and do precast pervious concrete. At the time, these weren't really available, but for a grant project out in El Rio, the community of El Rio, we brought a company called Stormwater out. They do this stuff in Maine, and they set up with Precon and Simi Valley to start creating modular panels. So now you have them set in a controlled environment. If anyone's ever worked with pervious concrete, it's extremely difficult and delicate. Too much working in the field closes the voids and it won't infiltrate. So it just makes sense to make a modular system like this that you can utilize. So this is an example of them at the facility, just pouring it in, rolling it out, and they have the set forms. They are the 4x5 panel size, or you can do 2.5x5. Same thing, you can do customized sizes, but it's going to cost more if they have to create the forms and do all that stuff. And then when the actual construction part of it is very minimal. Once you build your trench, you do your backfill and compaction of your rock aggregate, then these basically snap in like Legos. You drop them off put chains in these lifting rings, you drop it in, slide it up against the next one, put in these spacers, slide in the next one. So you can basically do a full street in a day, no problem, once you have the trench and everything ready to go. The benefit of these too is for O&M. This is one reason we put them in, is they have lifting rings in them. If they ever get to the point where they're fully sediment impacted and they're no longer infiltrating, we can actually put the rings in there, lift them out, turn them over, pressure wash the bottoms, clean them all out, put them back in. So it's a way of saving material costs long term as well. With the poured in place, you simply have to demo and replace it, and that can be very expensive. I want to leave my presentation, the last 2 slides here, just some more information, some stuff that I've run into in a few projects that a lot of people, for the most part, aren't familiar with or didn't know were requirements. So one of them is dry wells are classified as Class 5 injection wells, which need to be documented with Region 9 of the EPA. So we ran into this at the government center with the dry wells we put at the bottom of our trenches. And basically, it's not something you have to pay for. It's not a permitted well. There's the rule of thumb that I have listed here. So in their fact sheets at this web address, complying with the inventory requirement means you are authorized by rule to continue injecting unless EPA requires more information or the permit is closed or your well is abandoned. So you have to basically just submit a form saying, this is how many I have, here's the lat long of where they are, they're constructed, they're in operation, they're for stormwater, and then in the technical portion they ask, how was it designed? You basically say, to meet MS4 permit requirements. So that's just guaranteeing you have your 5-foot separation, you're meeting the MS4 permit requirements. They keep it on file. In case in the future there's ever some groundwater degradation or some sort of spill, things like that, they want to go back and they have record of, okay, who's injecting water? We can go back and check if they're still operational or if they're doing something they shouldn't be doing.
Doesn't the county have a requirement for wells if they're deeper than 50 foot? You've got a permit with the county well department?
Yes. These dry wells we put in are only 15 feet, so they don't qualify for a lot of those, but that would be more discussion with our groundwater department because they do have ordinances and regulations for what are permitted wells that they would monitor and give permits for.
So you didn't need permits under that depth?
We did not have to, no.
50, I thought.
Correct. And in my discussions with EPA and the people that administer this underground injection program, they're not that concerned about just standard stormwater. If it's from an industrial site, they are. One more reason why industrial infiltration is not generally recommended. But if it's just urbanized stormwater, they're not that concerned with it, especially if you're showing you're meeting your separation requirements per the MS4 permit. The one thing I did want to identify on here too is Most people, if they're familiar with injection wells, they probably heard the term their depth is greater than the largest surface dimension. So basically they're deeper than they are wide is what they're saying. A lot of people have heard that and they say, oh, I don't need to do that. My bioretention facility is only 5 feet deep. The key thing you have to look at is a subsurface fluid distribution system. So let's say if you have a driveway and you have a bioretention facility and a secondary bioretention facility and you have a perforated pipe or something that's bringing that water across, even if it's horizontal, subsurface for the purpose of distributing water subsurface, then it qualifies as an injection well. So that's just something to keep in mind. And we ran into the same thing here at the government center is infiltration trenches are not classified as injection wells because they're not as deep as they are wide. But as soon as we added piping in there for the vertical piping, now it's deeper, so now it qualifies. So we did have to register these as part of that project. And the last one is for antimicrobials. I'm sure each of you have spoken to vendors, say, oh yeah, or antimicrobial blankets or antimicrobial this, 99% removal rates, or 99% kill rates, I should say. Because if anyone says antimicrobial, it technically means they're killing organisms, and if you're killing something, you have to be registered under the California Department of Pesticide and Regulation. So if people come up to you and say, oh, this kills 99% of the bacteria, put it in, it's actually illegal to do it unless it's got registration from Cal DPR. California and a few other states require this. There's plenty of states that don't. All they require is EPA registration. And the EPA registration, I've had that. A couple vendors come to me and say, look, we have an EPA registration. I'm like, well, I'm sorry, this is California. We can't do that. And I ran into this in a grant project, and that's the only reason I even stumbled across this. But I think it's important to let people know about. The other item is, I think there's only 3 products specific for stormwater antimicrobial use that have tried to go through the Cal DPR process. 2 of them have been denied from the environmental, so it goes through a rigorous, like, is it going to leach other stuff into the water? Is it going to be a problem other than just the antimicrobial? And there's only 1 that actually just got approved to go through it, so I will be meeting with them very soon to see if it's something that's actually practical. The one thing to identify in here, though, is even if they pass the Cal DPR requirements, Cal DPR doesn't qualify that it does meet 99% antimicrobial. All they're testing is it's not going to be a detriment to downstream water bodies. So even though they say they got approval for antimicrobial, it doesn't necessarily mean it's the best bacterial treatment. For instance, there's a fine line between saying, okay, I'm killing microorganisms or I'm removing them. Because through several media products, you're going to have some removal rates of bacteria anyways, so that they don't need qualification as an antimicrobial. But as soon as they say antimicrobial, they need to be registered. So that are my final slides. Is there any questions here before we... Yeah.
Is there anything requiring us to have antimicrobials?
There's not. The biggest issue is bacteria is the most difficult pollutant to address in stormwater, especially in Ventura County where about 80% of the area you generally can't infiltrate water. So you need to come up with other means to get rid of bacteria for dry weather and wet weather TMDLs. And so if an approved antimicrobial gets approved and it's very effective, that's something that a lot of people will be interested in because most municipalities and vendors, things like that, aren't able to treat water like they need to meet TMDL and water quality objectives.
Can you say again the name of that company that cleaned the water statement?
It's Bunyan Industries is the company that manufactures the device. And as part of the O&M contract that I set up for the pervious concrete, I required anyone bidding on the project to purchase that equipment and maintain it.
Question. Dry wells or loading docks? Compress the loading dock, and then you have a discharge to dry well. Is that right?
It's a tough question. Off the record, we could talk about that, but no. You can really do anything if you can show appropriate pretreatment. It depends also what the loading dock is unloading. If there's citrus, things like that, where it's not an actual hazard, then yeah, it's fine. But if you're talking oils and greases or paints and stuff, it might not be the best.
Sure. Any questions? All right. I appreciate all your time. Oh, sorry.
Where will the PowerPoint presentation be available?
Yeah.
just make sure your email is on the sign-in sheet. Make sure everyone signs in, and depending on the next couple of days, it'll definitely be early next week, but maybe this week I'll email it out to everybody. And also, when the video links are ready, I'll email it out to the same.
And I do have one more comment, actually. I'd mentioned the word discretionary quite a bit today. That's something that when we're doing reviews, a lot of the time, maximum extent practicable does apply. Sometimes it's very difficult or impossible to meet some of these requirements, so we have to be a little lenient. In some cases, though, it doesn't make sense to be that lenient. For instance, with all the TMDLs and all the water quality issues that the municipalities, cities, and counties are listed in those TMDLs for responsible, it's basically if these developments are not meeting their treatment requirements and they discharge to our MS4 permit, and then those discharges go to the TMDLs, we're responsible for that discharge. So we want to make sure that wherever we can, we be as strict as we can so that it helps us in the long run as well, hopefully not requiring us to do as many large projects to treat water to the water quality requirements.
Where did you want us to place the evaluation?
Back table, did it?
Back table?
Staff there. Is that a big round of applause? Thank you, Troy. Thank you, Oldcastle and Contact for all your great presentations. And thank you all for participating. I hope you got something out of it. And yeah, thank you very much.